Morning, guys. Today we're going to be talking more about rock classification and formation. Remember that we always classify a rock by how it's formed. We saw in our warm-up yesterday, it has nothing to do with where it is. It's all about how it is actually formed. And yesterday we talked about subduction and uplift, and then you had to make those different types of rock in your simulation yourself. And then you had your exit ticket, which we're going to go over really quickly together. In number 1 in our exit ticket, we have something that's starting as an igneous rock. After it cooled off and hardened, it turned into a metamorphic rock. So what we're missing is that piece in between. What process actually caused it to go from igneous rock to metamorphic rock? So your best answer choice, or best answer you could have written in, is right here. Igneous rock was subducted into the mantle and exposed to heat and pressure. The two things I was looking for here is subduction and then heat and pressure. If you had either one of those, I would mark it right. If you talked about igneous rock being subducted to form metamorphic rock, absolutely. If you said that it was exposed to heat and pressure, absolutely. I would take either one of those answers. If you put them both together, even better. But metamorphic rock is always going to form from heat and pressure due to subduction. For number 2, we had metamorphic rock, and then it was swept up into a volcano and turned into magma. And what we wanted to know here is what type of rock is the result of cooled, hardened magma. This is one we've been talking about for a little while, so I think most of us did pretty well on this one. But the magma made from metamorphic rock cooled on the surface of the earth and became igneous rock. So it started off as metamorphic rock. Once it cools down on the surface of the earth, it is igneous rock. Anytime magma cools, it is going to form igneous rock. So what we're looking at is our big question for our chapter. What we've learned so far is that the rock of the Great Plains and the rock of the Rocky Mountains have the same mineral composition. And we've also talked about how they could be different types of rock based on how they formed. We figured out that the Rocky Mountain rock is an igneous rock and that the Great Plains rock is sedimentary rock. So our question that we're trying to figure out is how could rock from one of the regions transform into a different type of rock in the other region? So either the igneous rock from the Rocky Mountains turned into sediments and became the sedimentary rock in the Great Plains, or the sedimentary rock in the Great Plains went underneath the earth, turned into igneous rock, and became the rock of the Rocky Mountains. Hopefully your simulation and your work yesterday maybe gave you a little bit of a hint as to which one of those scenarios would be true, but we're going to keep on looking at some evidence and see if we can figure it out for ourselves. So today's big question is, how can the same material continuously form different types of rock? And the answer to that question is called the rock cycle. You're going to see a lot of different rock cycles. Anytime you study the rock cycle, whether it's now or in 8th grade or even beyond that. And some of them will look really simple. Some of them will look really confusing. And they always have these arrows and are showing different processes going to different things. One thing to point out in these rock cycles, though, is that the arrows that are pointing to one thing will always be the same. For example, yesterday we learned that metamorphic rock is formed from heat and pressure. So if you notice, every arrow that is pointing at the metamorphic rock, meaning it's making metamorphic rock, says heat and pressure. Up here says heat and pressure. So anytime something is making metamorphic rock, it's coming from heat and pressure. Same thing, for example, sediments. No matter what they are starting as, sediments are always formed from weathering and erosion. So if igneous rock turns into sediments, well, look, that process is weathering and erosion. Metamorphic rock, weathering and erosion. Sedimentary rock, weathering and erosion. The same process will always form the same result. So if you can remember what is forming what, filling out these rock cycles can actually be pretty simple, and it might help you to look at these as a reminder of like what process is forming what material or what type of rock. What we're going to be looking at today for most of class is actually an interactive rock cycle. So you're going to find a link in your website, and that link is going to take you to, you're going to find a link in your Google form, and that link is going to take you to this website. And there's only 2 parts of this website I want you to do. The part that says how rocks change and the part that says the rock cycle diagram. So if it opens you up on introduction, don't worry, you don't need to go through either of these. We're going to save a little bit of time and skip right to how rocks change. So you will just click right up there, how rocks change. And what you're going to have to do for this part, it's only a few pages. You're going to read through your introduction and through each process. And as you do that, there'll be an option to watch a little simulation here that describes what is happening. And each time you see that, I want you to hit watch until it is all done. So if there's another step, you'll continue to hit next. But for this one, it's just one. So you'll watch it through, make sure you read all of this, and then hit next at the bottom to get to the next one. Once you've gone all the way through, it'll ask you a few questions, and then it will take you on its own to the rock cycle diagram. So you don't need to click anything to get here. It will take you there on its own. And you can take a second to look at the rock cycle diagram. You can click on things and actually watch that simulation again until you feel pretty comfortable with what happens in your rock cycle diagram in order to form each thing on your rock cycle. You can even look at different types of rock and examples of different rocks. And then once you're done looking at it to start, you're going to hit done. And there will be an option to do a short little 5-question quiz. And if you get it right, it will fill in part of your rock cycle. Each time today that you see your score at the end of an activity, I want you to, if you're in a live class, raise your hand and let me know what your score is. I'm going to come around and keep track of that. Once you're done and you get to a page that looks like this, where it says test your skills, you do not need to hit next. So when your screen is red, take that as a sign that you should stop and go back to your Google form. Your exit ticket today is not in this page, it's in Google Forms. So when you get to this page, you'll go back to your Google form and you will complete a 4-question multiple choice exit ticket that I'm going to collect for a grade. So make sure that it is done. Make sure you get this practice in these 2 sections before that so that you have a little bit of practice looking at the rock cycle. Once you're done with that, make sure you submit it because it will be a grade. And after that, you are done for the day. Tomorrow, we're going to explore a little bit more evidence and try and figure out what actually happened between the Rocky Mountains and the Great Plains, which one came first, and how did one type of rock become the other type. All right, have a good day.